Hello children. Today we'll study about curves. Curves means in a paper, whatever you draw, that means any curve, if I'm drawing like this, a straight line, or like this, all these are curves. Okay. So any result of your doodling are called curves. That means anyway, if you're drawing like this, like all these are curves. Okay. Now, usually if you're drawing a curve, what will be in your mind? It should not be straight. Curve means it should be like this, like that's what normally if you are in everyday usage, curve means not straight. But in mathematics, even a straight line is a curve. Okay, any straight line you can consider as a curve. This is a curve. Anything can be considered as a curve. Now you can see in this, you can see some curves already here in blue color. Okay, in this curve is crossing itself. Crossing means you can see it is crossing like this. It has gone like this. It has become like this. It has crossed. See, and the seventh one also, it is crossing like this. It is crossing means it is cutting like this. Other curves are not crossing. It is like this only. This is also not crossing. Crossing means it should go like this. So here 3 and 4 are crossing themselves. Okay. Okay. So the curves 3 and 7 cross themselves, whereas 1, 2, 4, 6 are not crossing. If a curve does not cross, it is called as a simple curve. So these all are simple curves. Like this, if you are drawing, this one is a simple curve. It is crossed. Okay, so it is not simple. Simple means it should not cross. Okay, till here, this is not crossed. So it is a simple curve. Now this is not a simple curve. Okay, this is a simple curve. That means curves which do not cross itself are called simple curve. Okay. So in this figure, this is a simple curve. This is simple. This is not a simple curve. This is a simple curve. These all are simple curves, but this is not a simple curve. Any curve which is crossing is not simple. Okay. Now draw 5. Now what you have to do is you have to draw 5 more simple curves and 5 curves that are not simple. Okay. 5 curves which are simple and 5 curves that are not simple. You have to draw in your classwork. Now, the first in this, you can see 2 figures are here. In this first one, this is not closed. Closed means like this. That means it will cover. No opening will be there. Okay. So this is not closed, but this is closed. Okay. So this curve you will call as open curve. That is not closed. Not closed means open only. This is open curve. This is closed curve. So before we study 2 types, simple and not simple. Now we study open curve and closed curve. Okay. So now what you have to do is, you have to draw 5 curves. Okay. Draw 5 curves which are open and closed. So before, what did I ask you? You have to draw 5 simple curves and 5 curves that are not simple. Now we have to draw 5 curves which are open and 5 curves which are closed. Okay. Now coming to the next. In a closed curve. So now we are discussing about closed curve. So here you can see one closed curve. It is going like this, like this. This is any curve which is closed like this. Okay, it is a closed curve. This is open curve. Okay, please understand the difference between closed and open curve. So in this closed curve, 3 parts are there. That means inside the curve. Inside means this part which is shaded with ash color, gray color. That is interior. Interior means inside. So 3 parts are there for a curve. Inside, that is interior. Interior of the curve. Second one is boundary of the curve. Boundary means this line. This line is there, no? This curve. Line means, sorry, not line. This curve is called the boundary. Okay. If you're drawing a curve like this, that pencil part, that is called the boundary. Okay. Exterior. Third part is exterior. Exterior means outside. That means these all are exterior. These part all are exterior. Okay. So interior, boundary and exterior of the curve. These are the 3 parts of a curve. Now, one more part is that interior of the curve together with the boundary. That means this boundary plus the interior, this full part, that will be called as region. So exterior won't be there. Okay, that is called region. Now in this figure you can see point A. You can see one point here, right? So that A is in the interior. B, you can see the point B, it is on the boundary, and C, you can see point C, that is in the exterior. Understood the difference between interior, boundary and exterior of a curve. Okay, now coming to another. You can see here all these curves. You can see this curve is made up of closed curve. It is a closed curve, and it is also simple curve because it is not crossing, nothing is there. It is closed and simple. So this curve is made up of line segments. You can see these are straight lines. Right, it is not curve. They are made up of straight lines. In this also line segments are there. You know what is line segment? A line with 10 points. Okay, so this is made up of line segment. This is also made up of line segment, but this is not made up of line segments. How is it? Here you can see this is not straight curve. Okay, so this is not made up of line segments. So these four are made up of line segments. So such curves have a special name. They are called as polygons. A polygon is just simple. It should be simple. It should not be crossed like this. Nothing should be there. It should be simple. So polygon is a simple closed figure made up entirely of line segments. So it should be made entirely of line segment. You cannot say these two parts are made up of line segment and this is not line segment. Polygon means entirely it should be made up of line segments. Okay. Now coming to the next one. Here you can see this is a polygon. Why is it a polygon? Because it is made up of line segments. All these are straight lines. So it is called as polygon. Okay. Now, line segments forming a polygon are called as sides. So line segment forming a polygon. So which are the line segments here? You can see this is a line segment. How will you write the line segment? Line segment DC. Okay. So you have to put like this. So here, so above all these you have to put a straight line. Then all it will be a line segment, right? Okay. So line segment DC. Okay, line segment DC. Then what is the next line segment? Line segment BC. BC or CB, whichever order you want you can write. Then comes AB. Yes, AB. Then which is the next one? AE. And then comes ED. So these are the line segments with which this polygon is made of. So these line segments are called as sides. What will you call them? They are the sides of the polygon. So here AB, BC, CD, DE and AE are the sides. Okay. Now comes the next term, that is vertex. Vertex means the point where two line segments meet. Meeting point of two line segments. Okay. This one. Wait. I will draw this once more. Okay. I'll rub this. Okay. Okay, now meeting point of pair of sides is called as vertex. So here these two line segments, that is DC and BC, are meeting at the point. Which point are they meeting? It is meeting at the point C. So C is a vertex. Then AB and BC, they are meeting at the point B. Then AE and AB are meeting at the point A. ED and AE are meeting at the point E. ED and DC are meeting at the point D. So all these points, clearly you can see from the figure itself, the meeting points of these line segments are called as vertex. Okay. So D, C, B, A, E, these are the vertices. Vertex means singular, vertices means plural. Okay. So they are the vertices of the polygon A, B, C, D, E. How will you name this polygon? You have to name the polygon as polygon. You can name in an order. So here you can name it as polygon A, B, you can start from this vertex, A, B, C, D, E. So A, B, C, D, E. You can stop it. Again, no need of starting at A. Okay, A, B, C, D, E. So this is how you will name this as polygon A, B, C, D, E. That's how you have to call this polygon. Okay. Now, any two sides with a common endpoint are called adjacent side. Now another term is coming, that is called adjacent side. Adjacent side means these two sides which are nearby. Adjacent, the meaning itself is near, which are near. So these two sides are near. So they are adjacent sides. Okay. So here AB and BC are adjacent. So AB and BC are adjacent. So we can write AB, BC are one pair of adjacent sides. Now which one can you write? Another one. You can write AB and AE. These two are adjacent because A is common for both, right? So AB and AE is another pair of adjacent sides. Then which one will be the next one? DE and AE. Okay, so here E is common. So DE and AE. Okay, then what will be the next one? I'm writing it here. So common point B over, A is over, then E over. Now coming to that is ED and DC. They are the next one. Okay, then which is the next one? DC and BC. DC and BC. These are the 1, 2, 3, 4, 5 pairs of adjacent sides of this polygon. Okay, adjacent means which are nearby. So in pair you have to write DC, BC, ED, DC. Like this you have to write. You should not write one after the other continuously. Okay, pair. It should be a pair. Okay, so they are the adjacent sides. Okay, now so which will be not adjacent in this figure? Can you say which two sides will be not adjacent? That is DE and AB, if I am considering, they are not adjacent. They are not nearby, no? And they don't have any common point. D is here, AB is no common vertex for them. So it is not adjacent. Okay. Another one is DC and AE. They are also not adjacent. No common point for them. Okay. So these are the not adjacent, non-adjacent sides. So adjacent sides and non-adjacent sides. Okay. Okay, coming to the next one. Now, the line segment joining the vertices which are not adjoint is called as diagonal. The line segment, I will drop this and I will explain, otherwise it will be full confusion for you. Okay. The line segment joining the vertices which are not adjacent, this is adjacent, okay. I will write it here. AD, JACENT, adjacent. So line segment joining the vertices which are not adjacent. So for example, so which two vertices are not, same way vertices can be adjacent and not adjacent. So E and A, they are adjacent because they are nearby. So these are the adjacent. Non-adjacent, so which two vertex will be non-adjacent? This E and this B, they are not adjacent, they are not nearby, they are opposite. So if you are joining these two vertices, we will get a diagonal. Okay, if you are joining not adjacent vertices, you will get a diagonal. I'm going to join this from E, I'm joining B. So this is a diagonal. Now, can you see another diagonal? Yes, A and C, they are also non-adjacent. So I'm joining this. So we have the next diagonal. Now A and D, that is also a not adjacent vertices. Then D and B, that is also not adjacent. E and C, that is also not adjacent. So these all are the diagonals of the polygon ABCDE. Understood? What is called a diagonal? Diagonal means the line segment joining the vertices which are not adjacent. Okay. Now what you have to do is name all the sides, adjacent vertices of the figure A, B, C, D, E. That is figure 4.15. That is this figure. This figure this is called as A, B, C, D, E. In this figure you have to find sides, vertices, adjacent sides. Then what else you have to find? Yes, these four you have to find. Sides, adjacent vertices of the figure A, B, C, D. You have to name the side. Okay. Now another one is, next question is, draw a polygon A, B, C, D, E, F, G, H. So you have to see how many sides will be there. That you have to see. A, B. So for example, if I am drawing it like this, A, B, C, A, B. So what is the next side? BC. So BC. Then what is the next one? CD. Then what will be the next? DE. Then EF. So from E we have F. From F, G. From G, H. And then A. So it will have some. How many sides it will have? 1, 2, 3, 4, 5, 6, 7, 8 sides will be. So anyway you can draw a polygon with 8 sides, and then you have to name the sides. So which all will be the sides of this polygon? AB, BC, CD, EF, GH, like that. You have to name the sides. Adjacent sides you have to write. Will be what will be the adjacent sides? I told you AB, BC. AB and BC will be adjacent side, one pair. Then what will be the next pair? BC and CD will be the next pair. Like that you have to write. Then vertices. Which are the vertices? A, B, C, D, E. Like that you have to write the vertices. Vertices means that points only. No. So A, B, C, D, E, F, G. They are the vertices. Then you have to write the diagonals. You know what are diagonals? For example, A and D. AD is a diagonal. So AD, line segment AD. Have to write as a diagonal. So this is how you have to write. This you have to write by yourself. If you want, I will explain it once more. If any doubt, I will explain it once more. That is, I will clear it once more. Okay, I will rub it fully. I will rub it. Okay, so we are going to draw an 8-sided figure. So I will start from here. 1. So we'll change this. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have to join this. I'll draw it neatly. Okay, now we will name this as A, B, C, D, E, F, G, H. Okay, A, B, C, D, E, F, G. This is the polygon. Okay, what are the sides? So you'll write sides is equal to. So how will you write the sides? Sides mean they are line segments. So you'll write A, B. Put a line segment above it, comma. What is the next one? A, B. Then what is the next one? B, C. B, C. Then what is the next one? C, D. Like this it will go on. So that's how you have to write sides. Then what is the next question? Now we have to write the adjacent sides. Adjacent side means nearby. So what are the adjacent sides? A, B and B, C. So you have to write it as pair. A, B, comma, B, C. Both you have to draw a line segment. So this is one pair. Okay. What is the next pair? BC and CD. That is the next pair. Okay. What is the next pair? CD and E. Like this you have to write the adjacent sides. Okay. Many more are there. Okay. You have to do it by yourself. So adjacent sides over. Then you have to write, what's it? Vertices. Which are the vertices? These meeting points are called the vertices, right? So A, comma, B, comma C, comma D, comma E, F, G, H. These are the vertices. Now we have to write the diagonals. So what are the diagonals in this figure? Diagonals means the line segments after joining the not adjacent vertices. Okay. So in this, these two are adjacent vertices, so you should not draw this. So what will you, I'll take another color. Okay. So these two are not, they are adjacent. They are on the same line segment, right? They are nearby only, no? So A and C, these are non-adjacent. So first diagonal is AC, line segment AC. What will be the next one? AD. So AD is the next diagonal. What is the next not adjacent vertex? Sorry, vertices A, E. Then what is the next one? So just join it. Then A, F. Then what is the next one? A, G. A and H, they are adjacent vertices, so you should not write that. Okay, so this is starting from A. Now again is there. Again, what is the next one? Now I can start from, now we started from A, now we will start from B. So B and C are adjacent. You should not start, you should not draw that one. B and D. So BD is the next diagonal. Then BE. Then BF. Then BG. BH. That is the next one. Then from where will you start? Then you will start from C. CA, CE, like that you have to do. All the diagonals, all the possible diagonals you have to write. Okay. Now coming to exercise 4.2. Nothing is there, simple. What you studied till now. Classify the following figures as open or closed. You know what is open? This is open, this is open, all are open. Which are not closed are called open. So you have to write which all are closed and which all are open. Okay. Now draw rough diagrams to illustrate the following. So any open curve you can draw. Just draw any one open curve. Any closed curve, either this one or this one. This is a closed curve. Any open curve and any closed curve you can draw. That is your fish. That is only an example. Second question is only any curve you can draw, which is one should be open and the A should be open and B should be closed. Okay. Now next is draw any polygon and shade its interior. So you know what is a polygon. Polygon is a simple closed curve made up of line segments. So this is a polygon. This is another polygon. It should be closed. It should be closed. Okay. And it should be simple also, right? So simple means it should not cross. So this is a polygon. So all these are polygons. Okay. Now simple closed figure. Okay. Simple you should remember. So now shade its interior. Interior means inside part. This part you have to shade using a pencil. Okay. Consider the given figure and answer the question. This figure they are talking about. Is it a curve? Yes. Sure. It is a curve. Is it closed? Yes, it is closed. Now what is it? Illustrate a possibility of the following with a rough diagram. A closed curve that is not a polygon. So can you tell me a closed figure which is not a polygon? See, this is a closed curve, but it is not a polygon. Polygon means it should be made up of line segments. So this is the answer. Okay. A. An open curve made up entirely of line segments. Open curve, it should be made up of lines. See, so I have drawn only 3 line segments. This is open only. This is not closed. This is open. So that is second B. The answer. A polygon with 2 sides. Is it possible to have a polygon with 2 sides? Polygon means it should be simple closed curve. 2 sides means we cannot close it. So such a polygon is not possible. Okay. So C you will write as not possible. Okay. So exercise 4.2 over. Okay. Thank you.